Hello, in this video I'm going to speak about a special type of steel members. As you can see here, in these pictures we have the normal steel shapes, and these steel shapes are created when the steel material is very hot. Then they can roll the steel and create the W section, or what's called in different parts of the world as I-beam. And you can create channels, you can create HSS, you can create different shapes. But you remember that the steel material is very hot. There is another way to create the steel shapes, and this way when the steel material is really cold, and we call it cold formed steel members. Now the steel members here, to be able to shape it, we have to create or to use thin materials, and this material will be a maximum thickness will be less than 3 millimeter. So the sheets will be less than 3 millimeters, and then we can create the different shapes of these members. As you can see, the regular shapes of the hot rolled steels are I section, W section, HSS, channels, and so on. Here in this case, where we have the cold formed steel framing, we can create something called stud, which will have this shape: track, channels, furring channels, and L headers. I'm going to go through these shapes one by one. And as you remember that the thickness of the material to be very thin to shape it in different shapes. So there is another name for the cold formed steel members. We call it light gauge steel members. And the first shape what I'm going to speak about is the steel studs. In the steel studs, I will have a whip which has a specific height, and then you have a flange and another flange, and at the end you have a lip. This lip gives more stability to the flange, and this member can carry normal force or bending moment in case of having wind load on it. If you remove these lips, then the studs can change to a track in a simple way. So the track will be in a U shape. However, we will see later that these flanges are inclined inside a little bit. So this angle is not 90 degree, it's less than 90 degree. It can be 88 degree, 87. It depends on the shape of or the dimensions of the track. There is another way or another shape which is the U channel, and as you can see here, the U channel is a little bit thinner and smaller than the track, and they are used for a specific purpose. You can have also furring channels which can be used to support facade members and external or maybe ceiling and external items. You can have here also the L header, which is an angle. It can provide framing or enclosure to some space or connect between different members. Now when we speak in details about the studs, you can see that the studs can be solid studs or they can have some opening here, and in this case we speak about perforated studs. And this opening, as you can see here, it helps in providing the service through the studs, or you can have also some channels to provide lateral support for the studs. Now the designation for the normal steel members or the hot rolled steel members, you can speak about W section or I section, C channel, HSS. Here we are speaking about the three members, which are studs, tracks, and channels. So we agreed in North America in one code, which we call it the S134, and that's North American code that includes Canada, US, and Mexico. And in this code, the agreement was to use S for the studs and T for a track, and the depth of the studs, it has here 600 S 162-54. These dimensions are the 600 are the, if you divide it by 100, it gives you 6 inches, which is 152 millimeter. S stands for the stud, and 162 is the width of this flange, which if you divide it 162 divided by 100, it gives you 1.62, which is 1/5 of inch. So that you have this flange thickness, and the lib is depends on the dimensions, so it's already included inside, so it doesn't have a special designation here. However, the 54 speaks about the thickness of the base material. So 54, if you divide 54 divided by 1000, then you can have 0.054 inches. So if you multiply that by 25.4 millimeter, then you can get the thickness in millimeter. So we have S for studs, T for track, U for channel, F for furring channel. So that's very important to understand the designation for that. To give you a hint about the one of my office project, as here it's a project in about 500 kilometers away from Toronto, and we use here the cold formed steel studs in combination with the other regular steel members. So they use it for the framing, and the contractor and the owner asked us to use that. That was 2004, to replace the timber, because the cold formed steel studs has more resistance for humidity and termite, and it's also light, so you can handle it in a very comparable way with the timber members. However, it has more advantage to resist environmental effects. Now, if we go in depth and look at the member designation here, you can have the stud designation as 162 S125-18. It has a lib, this lib here, of 4.78 millimeter. So as I said, the lib, it doesn't come into the designation, but it is important to provide stability for the flange. So you can start having studs with the designation 162 S125-18, and it goes forward to 250 S125, 362 S125, and 362 S162. And as you notice that I didn't mention the thickness, because the thickness will change. It's the thickness of the base metal. So that's for the studs. And here you can see different designation or more details about the stud, with the area, depth, and moment, and some moment of inertia, and the section modulus, so on. So the other one is the track section, and as you can see, you have a flange and web and another flange. As I mentioned before, the corner is less than 90 degrees, and here you can have it goes inside. So if you combine a stud with the same height with the track, you have to open the track ends a little, the flange a little bit, and then you can insert the stud inside the track, and you are combining composite member. And in this case, with this angle coming back with less than 90 degrees, it can hold the studs within it. Now you can have the studs in different ways or a function. One of the function is to have it to as a vertical member, like the studs in the timber, like 2x6 or 2x4. But here we are using most of the time to 600S 162. So that's the most common one. So it can be vertical, or it can be used also as a horizontal joist, and that can replace a timber joist 2x6, 2x8, 2x10, and up to 2x12. So the studs now is really comparable with the timber joist if you are using them as joist. And here you can have the table, and you can have some resistance. And if you are going to use the studs as joist, now it can be unperforated, so you don't need to have most of the time the perforation on it to get more resistance for the joist. Now if you are using the track is 162T 125, and also 362T 125. You can have the track here, going back to it, you can have the base thickness, base design thickness It depends, as I mentioned, the maximum thickness what we can have for the cold formed steel or light gauge steel members is less than 3 millimeter, and here you can see the maximum thickness is 2.59. Still we can have 6 inches tracks and 8 inches tracks. And if you can have a U section, you can have 75, which is very small channel that can go inside the track in the perforation, and then it can provide more support or lateral support for the studs. You can have 150 U, 50 and 43, and you can have it 45. You can use this table to find out the materials of the studs. Now, one of our drawings in my office, we provided this table, this notes at the beginning to make sure that everyone who is going to work on the project understands the designation of the steel members. And here you can see 362 S 162 43. So we provided the thicknesses here and also for the track. And as you can see, you can use the number 10 screws. You can support it also with existing flooring, and that can be also used healthy. The good thing about using the cold formed steel is that you can provide or you can create combination from the different members. Here you can have 600 S162 the stud, which is the outside, the lower one here. You can see that as a stud, and then you can put within it another track, so you are creating a combined or closed section here, and that can provide more resistance as normal force and also for the torsional resistance. You can get the studs 2 back to back. You can get the studs 2 to 2. You can have studs 2 like here 2 to 2, and also you can have one track from the other side, and you can connect the track to each flange of the stud by using the screws. And you have type 5. You can have first of all one stud like that, the other stud with back to back, and then you can, after you fix them with the screw, then you can add the other studs from the outside, and then you can weld them.